yesterday means on Saturday we were solving the NCERT exercise of this chapter, units and measurement. And in this lecture, in today's lecture also we will solve some more numericals, remaining some more important numericals from this chapter. And we will start the chapter 3 also in today's lecture, and that is the motion in a straight line. And student, you should know about your unit test first is approaching. It is going to start by 27th of July, and physics test is scheduled on 29. And for preparation of this test, you should know your syllabus first. The syllabus for unit test first is chapter number 1, chapter number 2 and chapter number 3. You know that chapter number 1 is a very small chapter, so you should focus mainly on this chapter, chapter number 2 and chapter number 3. So we have completed chapter number 2 almost, means we should discuss only some more numericals, two or three numericals here, and we should start this chapter number 3 also in today's lecture. So let's see question number 2.16. See on the screen the question number 2.16. So in this question, radius of the hydrogen atom is given. Radius is given, that is 0.5 angstrom, and you know that the angstrom, you can convert this into the meter by 0.5 into 10 power minus 10 meter, because 1 angstrom equals to 10 power minus 10 meter. Also, you know the number of atoms in 1 mole of hydrogen or any ideal gas is number of atoms in 1 mole of hydrogen equals to 6.023 into 10 to the power 23. This is an Avogadro number. So here we have to find the volume of these numbers of hydrogen atom. So first of all, you should know the volume of first one atom. So atomic volume of one atom. You know the shape of the atom is considered as a sphere, so its volume is 4 by 3 pi r cube. 4 by 3 pi r cube is the volume of one atom, where r is the radius of the atom. So atomic volume of n atoms. N means this number, because this is Avogadro number denoted by capital N. So we have to find here atomic volume of n atoms, matlab 6.023 10 power 23 atoms, because in the question given we have to find the volume of 1 mole, and 1 mole contains these numbers of atoms. So finally I am writing here atomic volume of n atoms equals to 6.023 into 10 power 23 multiplied by 4 by 3 pi r cube. See here, भाई एक का वॉल्यूम इतना तो n का वॉल्यूम कितना, so n multiplied by this volume of one atom. And in this expression, you know the r is 0.5 10 power minus 10 meter, pi is 22/7 or 3.14. So by putting these values in this expression, you can calculate the atomic volume of hydrogen in 1 mole. I am leaving this expression because for solving this expression it will take time, and I want to utilize your time and my time also in this video for solving some more numericals. So I think you can calculate this expression by putting the values of pi and r here. So this will be answer for the question number 2.16 here. Now see in question number 2.17 on the screen. The question says the atomic molar volume of 1 mole of hydrogen molecule is 22.4 liter. It is constant. You know that about the molar concept. कि molar volume of a gas at standard temperature pressure is fixed, that is 22.4 liter for 1 mole. So here we have to find the ratio of this molar volume and atomic volume. So let's find the atomic volume by the same way as we solved for the question number 2.16. So atomic volume of 1 mole of hydrogen molecule. Here it is given hydrogen molecule. In the last question it was hydrogen gas, है ना? It is given hydrogen molecule, mole of hydrogen molecule. In the last question it was hydrogen atom, H only. Here atomic volume for 1 mole of hydrogen molecule, that is H2. So it is equals to again Avogadro number multiplied by volume of, जैसा लास्ट क्वेश्चन में किया है ये पोर्शन उतना ही वही सेम है, n equals to volume of 1 molecule. So n is 6.023 into 10 power 23 multiplied by volume of 1 molecule. It is 4 by 3 pi r cube. And here r is given 1 into 10 power minus 10 meter, 1 angstrom only. So 6.023 into 10 power 23 multiplied by 4 by 3. You can put the value of pi 3.14 and r is 10 power minus 10 whole cube. So by solving this expression you will get the atomic volume of 1 mole of hydrogen molecule in meter cube, because now radius is in meter, so the volume will be in meter cube. In the question we have to it is given to compare the molar volume and atomic volume. Molar volume, listen, this is given in meter, liter. So first of all you have to convert this into the meter cube, because for comparing two quantities both should be in same system of unit. So it is in meter cube, so convert this into the meter cube also here. So you know the relation between liter and meter cube, कि 1 liter equals to 10 power minus 3 meter cube. So it is equals to 22.4 into 10 power minus 3 meter cube. Now see here, these two quantities, this is molar volume and this is atomic volume. So if it is not clear, I am reading it again. It is 22.4 into 10 power minus 3 meter cube. So by comparison of these two, we have to divide this molar volume by atomic volume. Again I am repeating, for comparison of these two quantities you will divide molar volume by atomic volume to get the ratio, and that ratio will be bigger quantity, and that bigger ratio of these two will justify this कि molar volume. I am repeating again, question में देखो दिया हुआ है कि why this ratio is a very big quantity. So आपको बताना है molar volume and atomic volume के ratio को solve करके दिखाओ. It is a very big quantity and that shows the molar volume is much more than atomic volume. And why? So you can say that because in molar volume it includes atomic volume plus intermolecular space also. I'm showing here, see this, these are the molecules. Suppose these are the molecules in 1 mole of the gas. So atomic volume matlab volume of all these molecules, and the molar volume means this complete complete volume, and that complete volume includes the intermolecular space also. जो space बीच में है वो भी include है. So molar volume is greater than atomic volume. So it's your work to get the ratio of molar volume to the atomic volume, and this will be a greater quantity, big quantity. Okay. Now see the next question on the screen. In this question we have to calculate the value of 1 parsec here. So we should use the definition of the parsec. It is also given in the question. See here, you know that if this arc length is equal to the 1 AU, that is the average distance, mean distance between sun and earth. So this arc length subtends 1 second angle at a distance. That distance is called parsec, 1 parsec. This is the definition of the parsec. So let's use this definition. So you know that the angle equals to arc upon radius. Using angle equals to arc upon radius. So angle is 1 second, arc equals to 1 AU. We have to find this. Radius means value of 1 parsec. So see here, angle is given in second. First of all, it should be converted in the SI system, that is the radian. We have to convert this into the radian first. You know the relation between radian and angle, degree, कि 180 degree equals to pi radian. 180 degree equals to pi radian, but the angle is given in second. So you know the 3600 second equals to 1 degree. 3600 second equals to 1 degree. So by using these two, we have 1 second equals to pi by 180 into 1 by 3600 radian. See the relation also we have discussed this about this relation कि 1 second is 1 second angle को convert किया into the radian, because we have to use the SI system for measuring these 3 terms. So this is the value of 1 second. Angle equals to, this is the angle, so pi by 180 into 1 by 3600, this is angle, it is in radian, equals to arc equals to 1 AU, and you know that the value of 1 AU, what is 1 AU? 1 AU is the astronomical unit, and is equals to the near about 1.5 10 power 11. So it is equals to 1.5 into 10 power 11 meter. Average distance, mean distance between sun and earth, and divided by radius means 1 parsec. So finally 1 parsec equals to 1.5 into 10 power 11 multiplied by 180 multiplied by 3600 divided by, see this, 1 parsec, and pi will goes here. Pi means 3.14. So by solving this value, it will comes into the order of 10 power 16. You know that 3.08 near about 3.08. You should remember this value. 1 parsec equals to 3.08 into 10 power 16 meter. So this is the value of 1 parsec, or you can solve this expression to get this value. So this is about the question number 2.19. See the next question on the screen. In the question number 2.20, it is given the distance between Alpha Centauri and Earth is distance between Alpha Centauri and Earth, it is equals to 4.29 light year. 4.29 light year. So first of all, convert this distance into the meter. Equals to 4.29 into light year. You know the value of light year. 1 light year equals to 9.5 10 power 15. So it is near about 9.5 into 10 power 15 meter. So this is the distance between Earth and Alpha Centauri, nearest star, that is 4.29 into 9.5 into 10 power 15 meter. Also we have to convert this distance into the parsec. So you know that the relation 3.08 into 10 power 16 meter equals to 1 parsec. 3.08 10 power 16 meter in 1 parsec. So for this distance, suppose we for solving this distance, suppose it comes x meter. The calculation I am leaving here for you. You can calculate this. So x meter is the distance between Alpha Centauri and Earth in meter. So for x meter, we have to convert this into the meter now. So x meter equals to 4.29 into 9.5 into 10 power 15 divided by this 3.08 into 10 power 16. This will convert this distance in parsec. See here, by solving this you will get 1.32 parsec. The distance between Alpha Centauri and Earth in parsec, it is 1.32 parsec. Now one more question is there in this part. We have to measure here the angular distance also, means parallactic angle. Suppose this is the position of Alpha Centauri and is measured, it is observed, you can say, it is observed by two diametrically opposite position on the orbit of the Earth. This is the position of Sun and Earth is revolving around the Sun on this orbit, in this orbit, and E1 and E2 are the two diametrically opposite positions on its orbit. And you know that the distance between Alpha Centauri and this is C, Alpha Centauri and Earth, we have solved. This is 1.32 parsec. 1.32 parsec. And this distance E1 E2 diametrically opposite position distance is equal to, this is AU, 1 AU more, that is 2 AU. पैरेलैक्स मेथड में हम लोग ने ये डायग्राम डिस्कस किया हुआ है. सेम इन द सेम वे द डिस्टेंस इज 2 AU and this is distance 1.32 parsec. So finally we have to measure this parallactic angle here. What is the angle formed by these two places? So suppose this is theta. So theta second is there, theta second. So now you can use again angle equals to arc upon radius. Angle is theta second equals to arc. What is arc? We should consider this one is arc. So arc equals to 2 AU and divided by radius. This is radius. So radius equals to 1.32 parsec. So finally theta in second equals to 2 divided 1.32, it is near about 1.5. So it is you can solve it by getting the exact value. I am writing here the approx value 1.5 and this will be AU upon parsec. So unit will be second of parsec. 1.5 second arc you can say here, arc of parsec. ठीक है, yeah, 1.5 second of arc. Yes, so this is the answer for angular displacement of this question. So this is all about the numerical portion, numerical exercise of this chapter, chapter number 2. Now let's start the chapter number 3. We will describe only the introduction of this chapter here. In this chapter, the chapter is, let's write, the chapter number 3 is motion in a straight line. So chapter is motion in straight line. Students, in class 9th you have discussed about the motion in straight line. If the body is moving on a straight path, on a straight line, then its motion is called motion in straight line or rectilinear motion. Actually, it is the one-dimensional motion. One-dimensional motion means, suppose the position of the object is represented represented in a coordinate system by x, y, z. This is 3 dimensions. This is in 3 dimension in space. Up to the class 10th, you have discussed about the coordinate system in 2 dimension only, x and y. But here x, y, z means the point exists in space, means 3 dimension space. So suppose the position of the object is represented by x, y, z, and after some time its position has changed by x, y, z1, or x, y1, z, or x1, y, z. So the motion is called motion in straight line. See here what happens. Original position x, y, z, and the new position is x, y, z1, means there is change in one dimension only. One dimension means it has changed in the position of z and along the z axis only. For this, there is a change in along the y axis only, and for this, the change in along the x axis only. So if the position of the object changes along only one direction, along only one axis, then the motion is said to be a rectilinear motion or straight line motion. We have not discussed here the coordinate system, but one dimensional motion, I am repeating again, what is one dimensional motion? One dimensional motion is the motion in which out of 3 coordinates there will be change in only any one coordinate, along x, along y, or along z. Any one coordinate changes, then it is said to be motion in a straight line. In class 9th, you have learned about the many types of motion, like a uniform motion, non-uniform motion, means average speed, means average velocity, means you have discussed about the difference between speed and velocity, difference between distance and displacement. You have discussed about the average velocity and average speed, difference between them, and you have learned about the different types of motion, means accelerated motion, uniformly accelerated motion, non-uniformly accelerated motion, and also in class 9th you have learned about the representation of different types of motion graphically. So all these means terms, all these topics we will use here. Means you have to revise all the topics, whole chapter of the class 9th chapter motion, for giving you the basic concepts about the topic, motion in straight line. Also it gives you the basic concepts about the motion. What is motion, है ना, types of motion, and equations of motion are also there in class 9th. Here also in chapter 3 we have to derive the equations of motion, but not in the way by which we have discussed in class 9th. Here we have to use one very important, very new method, that is called calculus method. We will derive the equations of motion in this chapter by calculus method, and for using calculus method you should know about the calculus topic. In the calculus topic there is a differentiation, integration, all are the branch of mathematics used in calculus. So here I am going to describe you the differentiation first. Differentiation. This is one of the very important and helpful mathematical tool used in physics. This is the mathematical tool. The mathematics branch students, they know about the differentiation, or they will know about this chapter differentiation in mathematics. And for biology students this is new, and you have to understand that especially the formula, how to apply the formula of differentiation in physics. Let's see what is differentiation first. Let's see what is differentiation. Suppose there is a function fx, that is x square plus 3x plus 5 suppose, and represented by y. See here, y is the function of x, that is x square plus 3x plus 5. So differentiation of y with respect to x, repeating, differentiation of y with respect to x are called derivative of y. क्या बोल रहे हैं इसको? Differentiation of y with respect to x or derivative of y is represented by d by dx of y or y dash. These are the methods to represent the differentiation of y with respect to x. Yeah, also you can write it as dy, that is dy dx, d dx of y. But what is the method to read this? d dx of y. But in practice generally we use dy by dx, but it's not the ratio. It is not the ratio of dy and dx. I will tell you what is differentiation. First see here, d dx of y or y dash is called derivative or differentiation of y with respect to x, and it is equal to the limiting value of change in y to the change of with respect to change of x with delta x tends 0. Try to understand. I am writing here again. It is equals to limit delta x tends to 0, delta y, delta x. This is the definition of differentiation. What is this? See here. Derivative of y with respect to x, yeah, differentiation of y with respect to x is equal to limit delta x tends to 0, t and ds tends to 0 of this ratio delta y by delta x. क्या है यहाँ पे देखो, you know that this is the function of y is the function of x, y is the independent variable, x is the x is the independent variable, y is the depending variable. ये depend कर रहा है x पर, and x here is the independent variable. So when you will change in value of x, it will change the value of y. So in this differentiation we measure the, listen here again, in the differentiation of y with respect to x we measure the change in y, small change in y with respect to small change in x. I am repeating, differentiation of y with respect to x is the measure of change in y, small change in y with respect to small change in x, where this small change in x tends to 0, मतलब जो change in x है that will be a very small change. Very small change means it approaches 0. जो change है x में it is too small that approaches 0. So this is about the differentiation definition. But in physics only we have to use the direct formula. Direct formula used in differentiation are, you can note down the differentiation formula, which are very important, very important in physics. Also in mathematics it is the branch of mathematics, but in physics they are frequently using in the chapters. See here, first formula, d dx of c, that is constant, is 0. Example, differentiation of 5 is 0. Differentiation of 5 is a constant with respect to x is 0. Next, differentiation of 5c equals to, sorry, this is I'm writing here, suppose this is c and it is yx. See here, differentiation of, this is the differentiation of product of two quantities, c is the constant and yx is the function of x. दो टर्म्स हैं यहाँ पे, किसका डिफरेंशिएशन करना है? प्रोडक्ट ऑफ टू क्वांटिटीज, वन इज कांस्टेंट c and second is the function of x, so it is equals to c d dx of yx. It means, let's see here, example for this formula, differentiation of, suppose 5 and x to the power 7, it is equals to 5 d dx of x to the power 7. मतलब अगर कांस्टेंट वेरिएबल के साथ प्रोडक्ट है तो कांस्टेंट इट विल कम आउट ऑफ डिफरेंशिएशन एंड इट विल जस्ट डिफरेंशिएशन ऑफ फंक्शन ऑफ द एक्स, function of the x only here. Now see the third rule, d by dx of x to the power n. Very important, this is a very important general formula for differentiation is equal to n into x to the power n minus 1. Differentiation of x power n with respect to x, क्या पढ़ेंगे इसे? Differentiation of x to the power n with respect to x is equal to n x to the power n minus 1. Example, d dx of x power 7 is equal to, भाई 7 के यहाँ पे n है, so 7 x to the power, इस एक्सपोनेंट में से एक माइनस कर दो, 7 minus 1, that is 7x power 6. So this is the general formula for differentiation. Many more formulas are there in differentiation. तो जो भी यूज में आएगा आई विल डिस्क्राइब बिफोर डिस्क्राइबिंग यूजिंग इन द एक्सप्रेशन. जो भी डिफरेंशिएशन फॉर्मूले यूज में आएंगे आपको, उसको यूज होने से पहले आई विल डिस्क्राइब द फॉर्मूला. सो फॉर दिस today's lecture, this is sufficient. You have to complete the chapter 2 by its exercise also. Its theory portion we have completed before, and try to get the formula in differentiation we have discussed here. So thank you very much and God bless you.